This demo refers to analytic composites. So let's assume that I have a model, which is this model shown here with the results. And let's say that I have, let me open the model, a bigger screen. So let's assume that this variable here, JSet, I have good reasons to believe that it is an analytic composite that has a set indication, a set definition of weights for the latent variable, for the indicators that make up the latent variable. There are 3 indicators, and that the weights are defined by theory as being such that the first weight is twice as large as the second, which is twice as large as the third. So what I'm going to do is to replace this variable, this latent variable, with an analytic composite with set relative weights that are defined by theory. I'm going to go to the option Explore, Analytic Composites and Instrumental Variables. I would choose the option Analytic Composite, and I will use the 3 indicators that are currently used in the latent variable JSet. So each time I choose an indicator, I get the weights are defined by default as 1, but they can be -1 to 1. And I have here the standardized weights for these indicators. So these are the weights that I give, and they're the relative weights. They're not necessarily the standardized weights, because the standardized weights are calculated by the software based on the standardized latent variable and the standardized indicators. Here the p-values associated with them, variance inflation factors. In some cases I will want these to be lower than 3.3, or in fact in many cases I may want that, because analytic composites are typically used when indicators refer to different dimensions of the same latent variable, this is generally referred to as formative measurement. These are the weight loading signs. I don't want them to be, any of them to be -1. That would be an indication of a Simpson's paradox instance at the latent variable level. And here are the effect sizes. I want these numbers to be greater than 0.02 by convention based on Cohen's measurement error theory. So theory, let's say that theory tells me that this weight here, which I'll keep as 1, is twice as large as this one. So I'll change this weight to 0.5. And this is twice as large as this one, so this one is going to be changed to 0.25. So now I have a analytic composite. I'm avoiding the word index here because index is a term that is used in SEM to fit indices, so I don't want to use that term, so I'm going to use this term analytic composite, which is essentially a latent variable that is a composite. It has no measurement error by definition, and that has weights. They're defined in relative terms by the user of the software. So I have the results, standardized weights. I have the p-values associated with them, low variance inflation factors, so there is no collinearity among them. They refer to different dimensions, arguably. The effect sizes are all greater than 0.02. So this looks good. Here I have correlations with the latent variables that exist in the model, and I have the Cronbach's alpha and the composite reliability for each analytical composite. I can save these results into a tab delimited file, and I can also create the analytic composite. Typically I'm going to do that, so I'll click on yes. The software will give me the option of choosing the analytic composite name. I'm going to call it JSAT. Notice that this analytic composite that I'm creating is highly correlated with the existing JSAT variable whose weights have been calculated by the software. This is often the case, but it's not necessarily the case in all situations, but it's often the case. So I'll create, and then the software will include this analytic composite as a standardized indicator into my data set. So to use it, I'm going to close out of here. I'm going to redefine my model, and I will edit this latent variable. Instead of using the original indicators, I'm going to use only one indicator, and this will be my analytic composite. The results should be more or less the same as they were before. So this is how this concludes this demo, which shows how I can define and use analytic composites in structural equation modeling analysis.